Having a look at the kinematics questions, the solutions to those asked in your second CET test. So here we begin. The questions shall be a combination of motion in 1D and 2D, but most of them can be answered from the options and with the help of some simple formulae. So here we go. The very first question, the horizontal range and relation between the range and height is given. It's 4 root 3 times. Well, whenever range and height relation is given, we have explicit relation h by r is tan theta by 4. Okay. So range is 4 root 3 times the height. So I'll just put this r as 4 root 3 times h. The h will go, the 4's will cancel, and we get that tan theta should be equal to 1 by root 3. Tan of which angle is 1 by root 3? 30-degree it is. So 11 goes with 1. The 12th one, they have asked the change in momentum suffered by the body along the y-axis only. So this is a case of vectors. So the initial velocity of projection, if I say this is theta, this initial velocity on y would be u sine theta, whereas at the moment of interest, at the highest point, there is literally no y velocity. So the y component here is zero. So what is the change in momentum of only the y components? M into final velocity Vy minus M into initial velocity Uy. Uy is u sine theta. But here they have given the angle as alpha, not as theta. So it should be mu sine alpha. What is the momentum? Momentum is mass into velocity. So with just that knowledge, you can try this question. The final velocity component at the highest point is zero. Initially, it is u sine theta. Now, moving on to question number 13, it is a horizontal projection case. We have done this a number of times where there would be horizontal velocity u and the package falls at some distance. They're asking what is this distance? At what distance will it strike the ground? The simple answer to this is since the initial vertical component is zero, it is being projected entirely horizontally. The time taken by it to drop the height h is equal to half gt square, where because this happens because uy is 0 and ay is minus g. Well, it's a minus h equal to minus half gt square, but the minuses cancel. So the time takes to strike the ground is t equal to root of 2h by g, right? In this time, with this speed u, it moves a certain distance forward. What would be that? X will be equal to u times square root of 2h by g. That is a distance a horizontal projectile strikes the ground from its point of projection. U is given as 216 kilometer per hour and H is given as 1960. There, it has different units, so we need to be aware of units before we use this. We can take this as a relation which will help in many problems. X is U times root of 2H by G. We have also seen how it is derived. The time it takes for the package strike round is given as root of 2h by g. In the same time, it travels a certain horizontal distance forward, which is u times square root of 2h by g, because distance is speed into time. So speed is u, time is root of 2h by g. I will go on to question number 14. A very famous one, has been asked even in JE couple of times. I plus 2 j cap is its initial velocity. What is the Cartesian equation of its path? Cartesian equation as in it is the equation of trajectory. How can I guess that from I plus 2j? Well, for the beginning, initially, how will we take this is given this I plus 2j, I know two important things. In the I component, in the I direction, the X direction, the initial speed was 1. In the J direction, the Y direction, it was 2. So what is the initial speed? Initial speed is a vector addition of this 1 and 2, which is root 5. So I can say U as root 5. And what is the angle? What was the angle with which it was thrown? Tan theta. Tan theta is the opposite by adjacent, which is 2. So with u as root 5, tan theta as 2, and g as 10, All I need is just to put these values in y is equal to x tan theta. We know the equation of trajectory, right? Y is equal to x tan theta minus half gx square times by u square times 1 plus tan square theta. We know the value of tan theta. We know the value of u square. U square would be 5 and gh 10. Put it and get the answer. It is all this question is asking is how can you find the initial speed and angle of projection with the help of vectors? We easily can. Question number 15. For a projectile, the ratio of maximum height reached the square of time of light is um interesting. We can answer this within 10 seconds by trying to understand. This is a solution for the 15th one. They're asking what is the value of h by t square? Well, what I can say is as follows. This distance is h. The time it takes for reached at this point is t by 2. Okay, it's t by 2. Now I can write the following relation. H is equal to uyt by 2 minus half gt by 2 square. How did I write this? I wrote this uh, from the y is equal to uyt plus half ayt square, those equations. Either I can write this, or the time taken for this thing to drop from the maximum height is also t by 2. The time taken to go to reach the maximum height is also t by 2. At the same time, the time it takes for the projectile to reach ground from the maximum height is also t by 2. And what was its initial velocity at that point? At this point, vertical component is again 0, right? So what I can do is I can say this h, right? Uy is 0 if I take this point as a reference is equal to half g t by 2 whole square. The time it takes, I'm just comparing the time it takes for the projectile to reach ground from the maximum height is nothing but half of the total time of flight. And what is the initial velocity at this point along the y direction? Initial velocity is simply 0. So h is equal to half g into t by 2 whole square. What this shall tell me later is half g, you know, t square into 1 by 4. I just need the value of h by t square. So if I take t square to the other side, h by t square shall be equal to g by 8. And what is g by 8? We need g by 8. G by 8 would be 10 by 8. 10 by 8 is 5 by 4. The answer to this question, what is h by t square? H by t square should be actually of, you know, to the square of the time of the flight is being asked. 10 by 8. 10 by 8 should be 5 is to 4. So we have got the answer 5 is to 4. And we haven't used any projectile formulas. We could have used h as u square sine square theta by 2g and t as 2u sine theta by g, square it and then divide. But that would be mathematical. But what I have tried to show you here is the physics way of doing. Instead of considering the first half of journey, if I consider the second half of journey, the equation itself will be very evident. It shall tell the ratio of h by t square should be equal to 10 by 8 or g by 8. Put the value of g as 10 and you will get as 5 by 4. So that was question number 15. Now what about question number 16? 16 is telling after 1 second, the velocity of a projectile makes an angle of 45 degrees with the horizontal. Hmm. So what is this trying to tell? After 1 second, the velocity of a projectile makes an angle of 45 degrees with the horizontal. Let's try to dissect that a bit. Let's try to go into depth at that sentence. At t equal to 1 second, the velocity of the projectile, let us say it has a velocity of v, is making an angle of 45 degrees with the horizontal. If I resolve it, right? If I resolve it, what I see is, since the vector is making an angle of 45, I can say both its horizontal and vertical component should be equal. Won't you agree? Its horizontal and vertical component should be equal. All right. And then they are telling that after one more second is traveling horizontally. So totally at t equal to 2 seconds, the projectile is found to be traveling horizontally. And we know that horizontal case happens only and only when it has reached the maximum height. So at this instant, at t equal to 2 seconds, it is traveling horizontally. So what does that mean? It means that 4 seconds is the time of flight of the projectile. Why? Because at 2 seconds, it is reaching the maximum height. So after 2 more seconds, it shall reach the ground. So totally, it takes 4 seconds for projectile to reach the ground. Cool. So from this, what data I can gather, we know that time of flight is 2 u sine theta by g, or otherwise I can say it is 2 times initial vertical component by g. That would give me the initial vertical component as a 20 meter per second. Okay. Now, what further can be gathered from this? And they tell that at t equal to 1 second, its both vertical and horizontal component are the same. So we know the equation Vy is equal to Uy minus Gt, where T I can put it as 1. U I have found it as 20. 20 minus 10 is 10. So the vertical component of velocity at equal to 1 second is 10 meter per second. But guess what? Since it's making an angle of 45 degree, this is also equal to the horizontal component, which is 10 meter per second. So I have the following data with me. I know that ux is 10, similarly uy is 20. From these, I can tell ux is 10, uy is 20. What should be this angle? Theta. So that tan theta should be equal to 2, or theta should be equal to tan inverse 2. And what should be the speed? Speed should be equal to the magnitude of this hypotenuse, square root of 20 square plus 10 square, which should give you root of 500. 500 is nothing but 10 root 5 meter per second, right? That is the initial speed, and that would be the initial angle, tan theta equal to 2. And 10 root 5. 10 root 5 would be a tad above 20. So I can say that initial speed should be 22.36, because root 5 is around 2 point something. 10 into 2 point something would give you more than 20, so 22.36. And the angle of projection is tan theta equal to 2, or theta equal to tan inverse 2. So 16:1 goes with B. For an object thrown at 45 degree to horizontal, 17:1, the ratio between H and R, undoubtedly, again, H by R equal to tan theta by 4. Theta is 45. So H by R is 1 by 4. So therefore, R should be equal to 4 times H. That's the only option giving that is C. Now, 18th one. 18th one says a projectile can have the same range R for two angles of projection. If T1 and T2 be the times of flight in the two cases, then the product of the two times of flight is directly proportional to a very old question. It had been a GEPYQ as well. So, a projectile can achieve a same range in two cases. If the angle is theta, angle of projection, and the angle of projection should be 90 minus theta. Only when the angles add up to, or when they are complementary angles, I can have the same range. For what? For same speed. For same value of u, for two different angle of projection, I can have the same range r. So I can write this for the very first one. Let us say the angle of projection is theta and speed is u. It achieved a value of r. I can say r, the horizontal displacement is u cos theta, the horizontal the horizontal projection velocity u cos theta into time of flight. What is the time of flight? Let me say it is t1. Similarly, for the second case, I project it with speed of u, but instead with an angle of 90 minus theta, I still get the same r. I can again write the same equation. R is equal to u. Now see the horizontal component of velocity is u cos 90 minus theta, or it is u sine theta. Why it should be 90 minus theta? Because only when it's 90 minus theta, for the same speed u, I can have the same range r. Let it take a time of flight t2. They're asking what is the product of t1, t2 proportional to. So let's multiply the two equations. So I have r square is equal to u square sine theta cos theta times t1 t2, right? Look carefully at this u square sine theta cos theta. We know that r itself is u square sine 2 theta, or u square times 2 sine theta cos theta by g. So I can write u square sine theta cos theta as, take g to this side, 2 to the other side. I can write u square sine theta cos theta to be equal to g r by 2. Now put this relation over here, u square sine theta cos theta is g r by 2. I have r on the RHS, r square on the LHS, so I can get T1, T2 should absolutely have something of r in the uh, LHS. So product of the time of flight should be directly proportional to the range. So T1, T2 should be proportional to the range, or r. This is the most time economical way. Without much formulae, you can arrive at this. 18th one goes with C. For a projection, range square is 48 times of maximum height square. Find angle of projection. Again, we use the same thing. H by R is tan theta by 4. But here they have given r square is 48 times h square. So therefore, h square by r square shall be equal to 1 by 48, right? So what should be h by r? H by r, take the root of 1 by 48. The root of 1 by 48 is again 1 by 4 root 3. So equate 1 by 4 root 3 to tan theta by 4, you will get theta again as 30 degrees. In fact, the question number 19 and question number 11, with which we started our journey in this discussion, is one and the same. 11th one and 19th one are one and the same. They have just told here, they have given the data in squares, whereas there it was just direct. So h by r is 1 by 4 root 3. We know the angle. Theta should be 30 degrees. Now, question number 20. A ball thrown by one player reaches the other in two. What is the maximum height attained by the ball above the point of projection? Okay. So here is where we can take advantage of symmetry. You see, initially, that the time taken by the ball to reach from A to B, the whole time is 2. So the time taken by the ball to reach from the maximum height to the ground, it should be 1 second, right? And what is, if I just analyze this half, the vertical component of velocity is 0 at the top, so uy is 0, and it takes 1 second, right? And and the height is h. How can I relate all this? H is equal to initial vertical component. If I just analyze this, is 0. So UYT goes to 0, is half g t square, where t is 1. So what should be h? H should be simply 5 meters. So height of the ball attained above ground is 5 meters. What did I do? I just considered the second half of the journey. The second half of the journey will take just 1 second. And initial component, if I take that as a reference, this point, the starting point is initial vertical component is 0. From there, I can obtain h as 5 meters very quickly without resorting to much formulas. That was question number 20. Now, question number 21. Three particles, blah, 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 same speed, key point, 30, 45, 60. We know 30 and 60 are complementary angles, so they should have the same range. So range of A and C should be equal. The only option that tells they're equal, only A and C is equal is C, hence the right option should be C. I don't even bother about examining is it greater than that of B or not. Same speed, complementary angles, the range should be same. So 21 goes with C. Now question number 22. Two vectors A and B at an angle of 60 degree with each other. Okay. The the resultant makes an angle of 45 degree with A. If mod B is 2 units, then what is mod A? If magnitude of one of the vector is 2, what is the magnitude of A? So we shall sketch 22 slightly, with a scheme. 22 can be made with a scheme. What is a scheme of 22? There is a vector and there is a B vector. The resultant of these, let me write, the resultant of these makes an angle of 60 degree. Okay. No, makes an angle of, let's say, I think my bad, I missed the key point. Resultant makes a 45 degree. Okay. The resultant, this resultant makes 45 degree, whereas the two vectors themselves, they make an angle of 60 degree with each other. Okay, this is a given data, and they have also given the value of B. The value of B is 2. What two formulas to go with? Well, we know the what is the formula for the angle made by the resultant with one of the vectors, that is tan alpha is equal to B sine theta by A plus B cos theta. Here alpha value I can put it as 45 degree, is given as a 2 and theta is given as 60 degree. You solve the equation straight away, you will get the value of A, one shot, right? So tan alpha is B sine theta by A plus B cos theta, where theta is angle between the vectors 60, alpha is 45, angle made by the resultant with one of the vectors, especially A over here. So that is question number 22. Now question number 23. The simple sum of two co-initial vectors is 10. Well, if I look at the options, then if I add the numbers given in the options, it should give me 10, but none of them gives them 10, which says this question has either a typographical error or it should qualify for a grace, right? Because no, none of the options add up to 10. But how can we solve this question given that it was some favorable, some, let us say, some given number n? How to solve this? Well, um, the resultant of the vectors, let me say A vector and B vector, its resultant is found to be perpendicular to the smaller vector. I have supposed that the smaller vector is A, the bigger vector is B, the resultant R is perpendicular. It is such a, the simple right angle triangle. Now, R is given as 8, right? R is given as 8. So in the options, if I subtract the square of the bigger number, which is the hypotenuse, no, if I subtract the square of the smaller number, the base from the square of the bigger number, which is the hypotenuse, in other words, calculate B square minus A square, I should be getting R square, or I should be getting 64. That's one way to look at things. So 144 minus 16 is not 64. 64 minus 64 would give you 0. So B and D eliminated. 196 minus 4 is not 64, but 100 minus 36 is 64. The question should have been instead, the simple sum of two co-initial vectors is 16 units and not 10 units. But now you know how to handle it. So if you look at the geometry, the square of the bigger number when square of smaller number should be 64. So the only option that satisfies is C. So 23 goes with C. Now, if sum of the two unit vectors is also unit vector, then what is the magnitude of their difference is asked. Sum of two unit means magnitude 1. So sum of two vectors having magnitude 1 is also a vector having magnitude 1. Again, 24 asks for a nice, geometrical interpretation. So if I have a 1 and a 1, the resultant is also 1 because all three unit vectors, that would only happen if this angle is 120 degrees. Angle between a vector should be 120 because this is an equilateral triangle. Now, how would you calculate difference? Difference is simply extend the same vector back. Now, this should be 1 and 1. I need to calculate what is this side, right? For this, what should be the angle between the vectors? Now the angle is not 120, angle is 60 degrees. For 60 degrees, how will you calculate the resultant of the vectors having magnitude 1? The angle is 60 degrees. Well, r is equal to square root of a square plus b square plus 2ab cos theta. A square, which is 1, b square, which is 1, plus 2ab, which is 2 times cos theta, cos of 60 degree, which is half. When I simplify, I get root 3. So 24 goes as a root 3, and hence we have a root 3 over here. So geometry will save you a lot of the time with simple, you need to retain the vector resultant and the angle made by the resultant with one of the vectors. It would help you a lot. Try to, sketch the vectors as much as you can. Question number 25 degree, 25th one. Another geometry based question. The key concept here is resolution. A force inclined at 60 degree with the horizontal. So I know a force inclined at 60 degrees. Its rectangular component in the horizontal direction, which means its horizontal component is 50. They're asking what is the vertical component. A right angle triangle opposite by adjacent, y by 50 is tan 60. Y should be equal to then 50 root 3. Y should be equal to 50 root 3. And what would be uh, uh, 50 root 3? So 50 times 1.7, right? Root 3 is 1.7, which gives you 17 times 5. 17 times 5 is around 85. The nearest answer I can get to that is 87 Newton. So 25 goes with C. The 26th question. Again, a train wala question, but here everything is in meters except the speed. So first thing is you need to convert the speed into meter per second, which is 45 times 5 by 18. Now 9 goes with 45 as 5, and this goes as 2. So it is a 12.5 meter per second. The speed of the train is 12.5 meter per second. The time taken by the train to cross a bridge of length 850. All you have to do is add the length of the bridge to length of the train and divide it by the time. You should get the speed at 12.5. So what would be the time? You add the two lengths, 850 and 150. It goes to 1000. So time should be equal to 1000 by 12.5. The answer has to do, if you simplify this, you will get 80 seconds. 1000 by 12.5 is 80 seconds. So 26 goes with C. Now 27th, a particle moves along x-axis. So, what is the initial velocity of the particle? You see, this resembles the equation S is equal to ut plus half at square, where the coefficient of t is -5. So u should be equal to -5. So right option to 27th one is A. Now, what about the 28th one? A particle has an initial velocity of 3I plus 4J, acceleration of so and so. What is its speed after 10 seconds? Here it's a nice question. We all know V equal to U plus AT, but what we don't know is we can also put a vector sign over each of them. It still holds good. Let's find a final velocity. U is 3I plus 4J and A is 0.4I plus 0.3J, and the time is 10 seconds. So let me put all the I's and the J's together. 3I, now zero point 0.4 into 10 is 4. So 3I plus 4I is 7I. And zero point 0.3 into 10 is 3. So 4J plus 3J is 7J. So this is the final velocity vector, which is 7 in the horizontal and 7 in the vertical. But they're asking speed, which means the hypotenuse magnitude, which would be around 7 root 2 units. So that would be option B. 28 goes with B. 29th one. The velocity of a particle is so and so, if position is so and so, what is its displacement after unit time? Unit time they have given t as 1. So given velocity, how will you go for displacement? Again, the beautiful flow chart. XVA, given V, how will you go to X? You will integrate. When you integrate, GT will become GT square by 2. So there should be a G by 2 in the option. Only two of them have a G by 2 in the option. When you integrate, this will become FT cubed by 3. There should be an F by 3 in the option. Only B has an F by 3. So 29 goes with B. But we eliminated here gt squared by 2 should become g by 2. Ft cubed by 3, there should be an f by 3. So option B satisfies. So without doing much calculation, we came to the right option. It's B. Now, question number 30. Two cars A and B are at rest at the same point initially. If A starts with uniform velocity of 40 meter per second and B starts with constant acceleration, what is missing is initial velocity of B is 0. Only when we assume this, we can, do the question. Then B will catch A after how much time? So here we are, A, and then let me call this B. They're starting from the same point, all right? They were on the same point, but the only difference is VA is constant with 40, whereas AB is constant with 4, whereas UB is 0. So when and where will they catch, or after when will they catch up to each other is the question. All right. So here is where we can um, get relative velocity going into the picture. Either we can use relative velocity or we can use kinematic equations. Let us say they both meet at a common point x at the same time t. This x is nothing but for A, it is speed into time, 40t. But for this B, x is equal to ut plus half at square because it's accelerating, but ub is 0. It should be half at square, right? For the first one, I can write x equal to 40t. For the second one, x is half into 40t square. Wait, they are not asking when will they meet, they're asking where will they meet. I don't need the x things because I will divide both of them. When I divide both of them, I can calculate the value of t. In other words, I should be getting 2t square should be equal to 40t. That would give you t as 20 seconds. So they meet after how much time? They meet after 20 seconds of time. Either you can do this by relative velocity, you can do this with the kinematic equations, but with relative velocity at this for this problem, it will require slightly more thinking. But with kinematic equation, straightforward. For two objects to meet, they should be at the same position at the same time. So we can solve for t. If they ask where will it catch, you can put the value of t and find the value of x as well. So these were the CET solutions for this test. Most of them can be done within 1 minute, 20 seconds or max 90 seconds. Hope you had to gain a lot from this discussion. Enjoy doing physics. Have fun with physics. Thank you. Till next time, take care. All the best.